Hi, I'm Jackie Garofano, Chief Technology Officer at CCAT, the Connecticut Center for Advanced Technology. Our team is bringing to you a series of videos all about model-based definition. Nasir Mannan, our principal engineer, is with QVI, our technology partner. Quality Vision International is here to show us how to use MBD to automate metrology workflows.
Hi, I'm Nasir Mannan. I'm the principal engineer here at the Connecticut Center for Advanced Technology. Welcome to another video in our series of videos that show you how you can really leverage model-based definition to automate production processes. Here with me today is Alex Garvey from QVI, who's an expert on using model-based definition, and he's going to walk us through how we can use the data set in QVI's technologies. Alex?
Thank you, Nasir. So the first part of the process for us normally starts in Evolve Design. So the design software is part of the suite of Evolve softwares. So there's Design, Smart Profile, Manufacturing, and SPC. There's some overlap in between them, but they all cover basically as much of the model-based workflow as we can. They also work with Zone 3, our inspection software that runs our Smart Scope machines. Design is used to correct and embed PMI onto a CAD model. So we can bring in any number of different CAD model types and embed PMI into them, or we can bring in an already fleshed out QIF model and correct the PMI in that model.
So you actually can perform the validation of the QVI format to verify that everything has been put on there correctly from the design perspective.
Correct. Most CAD softwares will allow you to apply GD&T to your model, but don't do much or anything to correct and validate it to the standard. In this demonstration of the workflow, this would be where a designer has received a model that has some PMI in it, and they are going to correct it, and then they would send it off to the quality department to do all the inspection, and then they will capture that information and send it to the SPC package. We have different ways to import information and models. So if you have an existing project in design, you can just start there. You can bring in just a blank CAD model, but we're going to import CAD with PMI. So when we bring it in, we can see the model, we can see all the dimensions, we get the list of features, all our tolerances, we can simulate data points, so we can generate data points on the model and induce error to try and simulate manufacturing error to see what the effects are on the results in our GD&T.
I see, okay.
So you can find out what might happen to your process before you ever start cutting apart.
Oh, wow. So it's almost as if you can do a little bit of that tolerance stacking analysis, right, in your software.
There is some tolerance stack up calculations that can be done. So we do have a tolerance stack up for distances between different features, so we can perform those calculations for you. But we can do a lot of simulations so you can find out, if you're a manufacturer, you know what types of errors you induce, and you can find out what impact that will have on your results. And then for correcting the GD&T, we have our GD&T proofing panel that will give us warnings and errors basically in different levels. So we might have things that are warnings that are absolutely not allowed. They'll show up in red. Things that mathematically don't make sense. It doesn't matter what standard you're in. But then we might have things like warnings. Each of these on their own is correct.
Okay.
And if you're just looking through it step by step, you'd never see it. This shows up because we're looking at all of the GD&T on the part all at once. And so this is a circular dependency where I've made datum A rely on datum B and datum B rely on datum A. And so it's telling me that I need to get rid of one of those. So I can say, find that dimension, or I can select it here and just say, I want to delete that. and then it goes away. I've made my correction. There'll be a history with the changes that I've made. And so if you're getting a CAD model that already has information from a distributor or a customer or someone outside your organization, you can track what changes you had to make to their print and then feed the information back to them so that they understand why you've made the changes.
Oh, great. So, and that gets exported as some kind of a
We can
report format.
generate that as a report. That would all be packed right into the reporting module. So we have the design view, so we can move the model around, and then we'll have the history and then whatever dimensions go along with it.
And that just happened with a click of a button.
That's just part of the standard. That's just what's in it, but you can customize it. So if there are different facets that you want to add in, if you want to have multiple views, things like that, you can basically just click and drag and drop it in and create additional views. I have a GD&T feature, and it has a material modifier on it, but the datum that it's referencing doesn't have a tolerance, so you can't do the math. It'll allow you, it'll show you that it's there, but it's part of a feature that is outside the initial step. And so you could create it, but we're going to tell you right away that it's wrong and then what to fix on it. So similarly, I can click on this, hit edit, and then I can pick which things I want to change. So if I wanted to remove the material modifier, I could do that, or I could go to the cylinder and add a tolerance to it. Both of those are acceptable solutions so long as that's what you're trying to do with your GD&T.
So, I mean, essentially a user almost doesn't even have to necessarily have the knowledge. Your software guides them actually through because you're adhering to the standards.
Correct. And it helps teach you along the way. So if I select a dimension there, over in the left side we have the explanation panel. And so every facet that is associated to that GD&T shows up here. So this is going to tell me about position tolerancing, material modifiers, axis interpretation, bonus tolerances, virtual conditions, basically anything that's related to it, and we'll quote it right to the standard. So this is right out of the ASME standard. So as far as a learning tool, it's really useful for helping understand what's going on. GD&T is not really a thing that's easy to learn in a weekend. It is a continuous process, and so in order to help people learn and understand and grow, this is very beneficial for that. And then we just have things that come down to recommendations. So you don't have to, but they're good practice. And so adding a form control to your primary datum is generally recommended. So I can come here and say, I want to add a tolerance. I could add a profile or a flatness. So just go ahead and add a flatness. If I want to do something like add flatness per unit area, it's warning me that I have to put a size in there. So if I did something that was illegal, it would stop me right away. It wouldn't even let me add it to the program.
So when you're adding GD&T in your software, there's really no way of adding it incorrectly.
You have to try really hard, but pretty much no. Yeah, so we can, well, probably should actually add that flatness. So put that on there, and we'll hit OK, and now that's gone away. And then an orientation, which is also a good practice, that all of your datums have some kind of orientation to your other datums. So again, it has to reference a datum feature. It won't let you do it if you don't. And now I've cleared my proofing panel. All my issues have been resolved. I can save this, obviously. Call you 1. And from there, I can hit send project to zone 3. So if I have zone 3 on the same PC and it's up and running, then I can just press that button and it'll show up in zone 3. If I'm not on the same system, so if I am a design engineer elsewhere, I can export as a QIF or an EIF. So I can say export EIF, and we'll say, just leave that as V1, so that brought in the name. And then we can go ahead and close this and open zone 3.
Now, zone 3 is responsible for what?
Zone 3 is responsible for running the actual inspection machine. So the CMMs, it's a multi-sensor CAD-based metrology software. So you'll bring in the CAD model, we can read in all of the PMI, all of the GD&T, all of the traditional tolerancing, all of that can come over. And one of the big benefits of that is you're not, well, there's two. One, you're not redoing the same work over again. Because if you're not using model-based engineering, it means you are figuring out all of your GD&T, then putting it on paper, then giving it to your quality group who's now going to have to decipher it and take everything from the paper and put it back on the model in the software. So you have essentially doubled the work and you've created an area where you are very likely to cause mistakes. This is the kinematic model of this machine, so we can actually see what the part will look like on it before we start moving anything.
And this is the zip light?
This is the zip light. This is a smart scope zip light. This is one of our smaller benchtop machines. So we go from anything about as small as this system to very large floor model machines, optics, touch probe, scanning probe, laser, things that are more classic bridge CMM machines.
Oh, okay, so full gantry type systems. Oh, okay.
Full gantry systems with articulating heads. So we'll go ahead and find the model and we'll load that in. It already knows the units that the model was created in, the project was created in, so we can go ahead and hit OK. So that'll bring the model in. Now, we don't really need to, because once we start writing the program, it will correct the location of the model, but we are able to adjust that starting position and rotation. So we can go ahead and say we'll go -90, and we'll move that in X and Y just to ballpark it into place. It by no means needs to be perfect. It just makes it a little easier to visualize. So now, because this is a QIF model and there is PMI embedded in the model, it's going to ask us if we want to generate the entire program from that PMI. With the right part, you absolutely can do that. You would have to create step templates that you would need to assign to the features that you define.
I see. So these are kind of strategies that are developed ahead of time per feature type.
Yes, and so if I'm not going to do that because there's several ways that we can program, but I'll hit yes for right now so we can see the dialogue. So it's going to look at some of the feature types that I brought in, and then it gives me different types, different strategies that I have already created. So if there's something that I use regularly, there is a feature type that occurs on all of my parts, that might be something where I build a strategy for it, so I'm not redoing the same work over and over again.
I see. So this is actually very powerful, because I see this as a way of capturing that knowledge that an experienced programmer may have. They can set up the strategies, and this essentially gives you a window where perhaps a novice or a beginner programmer comes in and they can just reuse those strategies that are already built in.
And these strategies can actually be sent to design so that the design engineer, if there are requirements that they know they need for certain features, they can define those in design and say, I want to use this particular strategy. So when it comes to zone 3, it just gets populated. If I were to pick one of these here, it would do it for every plane that is being referenced, but I can also open this up and pick individually which one I want to use. But we'll close this for right now. We'll use some of the strategies later, but there are different ways to go about programming. So the first thing we'll want to do is to locate the part. Now, if we were doing this in more of a production environment, we would probably have a fixture, we would have a system alignment, and so we would be able to just call up the system alignment and the part would be pretty much exactly where we want it to start, and that would kind of replace any manual alignment that you were working with. In this case, we're not, so I'm going to do a quick manual alignment. So I'm going to grab that controller from behind you real quick. So I can open up my metrology tree here, and this is everything that was brought in with the model. So we have all of the features, all of the datums, all of the tolerances, everything is embedded in it. And so I can program a couple of different ways. I can start with the features and I can just start picking features and I can add my tolerances later. Or I can go in reverse and I can pick a tolerance and it will add all of the required features to the project, and then I can go through the project and add my finders to those steps. So I could add to routine, or I can add to routine and edit. And so if I add to routine and edit, it's going to take whatever tool I have active and it will add it right to the step. But I should also be able to just grab one of my pre-made templates here and drag it in, and it's going to give me all the focus points. It will use that strategy and apply it to my project. Now, maybe there are going to be things in there that I don't like or I want to change. So I could still use path generation and generate my path, and it'll pick where all of the points are going. Or if I get rid of this and add it back again, we can say add to routine and edit, and it will add the focus tool in, still use path generation, but I can also just click right on the model and pick my data points. And I can put in safe points this way, so if I'm moving around the part, I can do it, and I still maintain control without just surrendering everything to the software. But I don't have to worry about naming. I'm not assigning datums. I'm not figuring out what it's related to. I'm not figuring out tolerancing. I'm never looking at a paper print. Everything is coming from this. I just have to get everything from this list into this list.
Okay. Yeah, that's very powerful to be able to reuse that data. That's built into the model, to the CAD model.
And this way we can also mix and match certain things. So datums B and C, those are planes that are on the sides. Those I'm probably going to want to measure with a touch probe, but I want to create a fully constrained alignment first, and I want to use my optics to do that. So I'm going to add in another couple of steps that don't have anything to do with the PMI or anything that the design engineer gave me. So I'm just going to say I want a line. And I want, say, this line, feature finder, got some backlight here. Backlight looks pretty good. And we'll generate a path. Yeah, that looks like that'll work. So I'm going to pick up a tool. It'll automatically move to the appropriate safe heights. But this is more where I can also use those strategies. So this is one that's for a cylinder using a touch probe. Now, I defined it against this feature, but again, you would use this if you had a feature that repeated across multiple different style parts that you made.
Yep.
So I can come in here and I can find the cylinder that I want. Now I can click through this way, but I can also click on the model and it will bring me to the right feature.
Oh,
so if you know the name of the feature, great, go find it.
Yeah.
But a lot of times it's easier to look on the model and pick out the one you're trying to get to.
Yeah.
So if I say add to routine, it's going to offer me up that step template. And I'll pick that and I'll hit generate. It lets your quality team, your CMM programmers, do the stuff that they're good at in measuring the part and not spending their time deciphering someone else's work and redoing that to get the results.
And that's really where the model-based definition is, fully utilized. Yeah.
Now, maybe I have something like this where I've got a pattern, I have a bunch of features, and I want to apply something to all of them, but I haven't created it yet. It hasn't, it's a new feature, it's one that I just haven't bothered to define yet. This is the first time I'm doing it. I can say, all right, well, how do I want to do this? I'm going to say I want to use optics. I'll use feature finder, let's say, and we'll add to routine and edit. I'll move to location here. And even though this is a cylinder, depending on what I really need out of it, from the GD&T purist standpoint, they would say that you need to get in there with a little probe and you need to measure a cylinder as a cylinder. You may not need that in practicality. And so I'm going to measure this as a circle, and I'll basically just treat it as a circle.
Okay.
And so as far as the software is concerned, I have measured a cylinder, but I'm going to use it to do a position, but I can still do that if I'm treating it as a circle.
I see.
But now I'm going to make a step template. And so I've made my optic step template. I will rename that so I know what I did. Optics feature finder, so one. So then I can come and find my other features here.
Using that same template.
Add to routine.
Oh. Nice.
Put that in, and now I've just given all of those the same strategy. And so when I say I want to do a position, I haven't added datums B and D yet, so it would ask me, it would add those for me, but I'll get to those later. So for right now, I can add the pattern if I want to, or I can wait, and when I add this, it'll add the pattern automatically. But now you can see it moving around the model, and obviously on the actual part, taking those measurements. Okay, so now we've added all of the actual measured features to the program. So everything from the features list, everything that we want is added. The pattern isn't yet, but that'll come along momentarily. So now we can go ahead and add all of the GD&T. So we don't have to figure out tolerances, we don't have to figure out associations. All of that stuff is done. So I can just say add to routine, There's reference metrology, so that's the pattern. So if there was anything else that I hadn't done somewhere along the way, something I had missed, that's going to get added, and then I can see what I've missed. So I'll hit yes. It brings in my pattern, brings in everything else. And it also brings things in simultaneous groups where it's applicable.
Oh, I see.
So things that are operating with different different datum reference frames, they're not subject to that necessarily. But if we have something that is, or where it's as far according to the standard where it applies, it'll bring that in as part of a simultaneous evaluation. So that'll all be brought in, it'll all be done appropriately, everything is associated to the correct features and datums, and if you scroll up and down, you can see what's related to what, everything will get highlighted. Then the next step would be to get the results out of Zone 3 and into Evolve SPC.
Thank you for joining us in this video in our series of videos that really show you how you can leverage model-based definition to automate production processes.
All that you've seen here today is available to you and your company, our team of experts, the technology, as well as tech partners that help to unlock the power of digital thread practice. Together, we're here to help you to incorporate model-based definition and digital thread practice into your business. I'm Jackie Garofano, CTO at CCAT. Thanks so much for watching.